Hello my dear students, how are you all? Welcome to our YouTube channel Diksha Karnataka. I hope all of you are doing very good, right? Today is day 17 of our ongoing series, which is 60 or 16 KCET Mathematics in 100 days. So right, we are maintaining the good energy. We have covered good amount of topics. We are continuing right now today with continuity and differentiability. Right sir, today is the session 4 for this continuity and differentiability chapter. What we have done so far, we'll do that in recap. So I hope you are all energized, prepared for the session. Make sure that you have notes, your notebook and your pen paper with you, so that you are not going to be distracted to start and solve the questions. So be ready for the session. Take a pause if you're not ready, and then start with the session with preparation complete. Take some water, breathe, and let's start with the session. So what is the first thing which is coming? Okay, which is the thing is recap, right? So I said we'll see what we have done so far in this particular chapter, which is continuity and differentiability, correct? So if you remember, first session that we took on this chapter was what, bacha? Was on limits, right? So first we have done was, first what we did, sir, we did limits. We did limits recap, right? We learned how to solve limits, what is the limits, when we have the requirement of limits, right? So we learned whenever the function is not able to be defined at all the points. So if the f of a is not able to be, so I can have a function where f of a cannot be calculated directly, means at x equals to a, I might not be able to calculate a function's value all the time. In that case, what I do is I try to find the limiting value of the function, right? So that's the need of the function, that's the limit, and then we learned the approach how to find it, left hand limit, right hand limit, right? We learned left hand limit, right hand limit. Then what we learned next? We learned about existence of limit. We learned about existence of limit, right? What was the condition for existence of limit? It was if I had, just give me a second. So if I had left hand limit and right hand limit equal to each other, left hand limit and right hand limit equal to each other, then I can say the limit of the function at that particular value exists. Okay sir, then what we went to solve a lot of questions. If you have any doubt, go ahead in my playlist and watch the part 1 of continuity and differentiability chapter. In that you will get this revision of limits, right? Moving on, we learnt about, in the session 2 we learnt about continuity, sir. We learnt about continuity. Okay, in this what we learnt? When can we call a function continuous, right? We learned the definition of it. What was it? If I have the left hand limit also given by L1 equals to the right hand limit which is given by L2, and these should be equal to what? The function's value at a, and all these values should be what, bacha? Should be a finite value. Should be a finite value, means the value should exist. Basically, if you want me to simplify it, the limit should exist, and that existing value of limit should be equal to the function's value at the same value a, okay, same x a. When that happens, I can say function is continuous, right? Then we learnt about then we applied the continuity to various functions using graphical method. Also we learnt whenever there's a break in the function. For example, if I take a greatest integer function, right? This is, yes, if I take it like this, open, close, like this is a break. So we learned that in every greatest integer function, whenever we are talking about integers, whenever we are finding the limit at integer, it is not continuous. It is not continuous. How? Again, go ahead, watch the part 2. We have done for various functions. We also did for some trigonometric function, they were continuous. We did for modulus function also continuous, sir. Okay, whenever there's a break in the graph, then the function will not be continuous, sir. Will not be continuous, sir. Again, this is all recap, bacha. These things are already done. I hope you have watched the sessions. I hope you have watched the sessions. Yes, sir. Okay. Then after applying the concepts of limit, continuity, we went to what? We went to the session 3 where we learnt differentiability. Where we learnt differentiability. Okay. Achha, one more thing. I am not doing very detailed recap. Okay. Because the videos are present there, and on these particular topics the videos are present there. Go ahead and watch it, okay, in detail. It's not that a longer video, it's a 1 hour 30 minutes video. You can go ahead, watch the sessions, you'll get all the concepts at one place. All right, so that's why I'm not doing a detailed recap. So I'm just recalling what we have done, so that okay, when we go ahead in the today's session, we'll have some bridge solving the problems. Okay, in differentiability, what we did, we first defined it, bacha. If you remember, we defined it first. What was the definition? If you remember, the definition was the function should be, or we learnt a concept, something was LHD and RHD. We learnt about LHD and RHD. From where we learned this? we learned from the first principle of derivative. What was that? It was written like this, if you remember, f of x minus f of c upon x minus c operated by limit at x equals to c, right? If this value, when you approach this c from plus side, you'll get what, bacha? You'll get RHD. When you approach the c from minus side, you'll get what, bacha? You'll get LHD. And after approaching this c from RHD and LHD, what you used to do? If they are coming equal, we said what? The function was differentiable. What did we say? If the LHD and RHD value are coming equal to each other, if LHD and was equal to given as like RHD, then we said what? The function is differentiable. Okay, this was the method using solving the first principle of derivative. Okay, what we did for LHD, if you remember, for LHD we used to substitute here x as a plus h, remember, a plus h, and for RHD, sorry, my mistake, very silly, but my mistake, forgive me, sir. For LHD, for LHD we used to substitute a minus h, and for RHD we used to substitute a plus h, right? A plus h. What did we substitute for? For x. So for x we substitute x equals to a plus h, and in that case it was a, not c. It was a, if you remember. It was a, not c. So if I'm taking a here, let's take a also there for to avoid any confusion. Okay. So when we found the LHD and RHD values, compare them. If they are equal, the function is differentiable at x equals to a point. If not, then we can say function is non-differentiable. Also, we learned the graphical approach. If you can draw the functions graph, if you have the functions graph, okay, if you remember, I took the example of sine x, right? And then what did I say? That if you take, if you take at any point, if you take the function's tangent, like, at any point you take the tangent of the graph, you get only unique, you'll get a unique tangent. When that happens, the function is differentiable. When at a point you can get two tangents, I took example of modulus function, right? And I explained you that at this particular point I have two tangents. I can draw it like this, I can draw it like this also. So I have, at the same point there exists two tangents. The function is simply non-differentiable, okay? So whenever there is a sharp corners, whenever there is a sharp corners in the function, simply the function will be, most of the cases it will be non-differentiable, okay? So just one concept from the figure, graphical point of view. If you can have unique tangents at every point, then the function is differentiable. That's it. Okay, the graphical approach that we did. Then we learned about differentiation of various functions, right? For trigonometric, for exponential, for logarithmic. We did not learn in detail. That's what we're going to do in today's session. But we learned simple formulas on them. I gave a list. I explained the list, I think, and then we solved questions on them, right? That's what we have done. So we have done what bacha last part was. This was 1, 2, 3, right? 4. Okay, the same thing. This is first principle of derivative. Remember this, first principle of derivative, sir, of derivative, correct, bacha. And what was the last one I said? We learned some differentiation formulas, right? Differentiation, we learned some formulas. Okay, if you want some example, we learned the first one was this, a power xn with respect to x. That's how we read it. Differentiation of a power xn with respect to x. This denominator represents what? With respect to variable. Okay, and I'll get what? A will be a constant. I can take it out and then I can write it as n times of x power n minus 1. Okay, I forgot one more thing we have learned. What we have learned? Some general rules, right? We have also learned some general rules. What was that? If you remember, some general theorems. Some general theorem has also been taught, sir. Sir, when did you cover all of this? Watch the videos, right? Watch the videos. These things are covered in the session. What is the first thing? First thing was, I think, product rule. Product rule was there, bacha. Second was what, bacha? Second was what? I think quotient rule. Quotient rule. And third was what? Chain rule. Third was what? Chain rule. Again, in today's session, to solve questions, I will be using all these theorems. Okay? Product, quotient and chain rule. I'll be using all these theorems in today's session. So I hope you have watched the video and learned that particular concept. If not, okay, first you pause this video, go and watch that session, learn these general theorems, how to use it, how to solve basic questions on them, and then come to this session and solve questions with me. Okay, let's move on to the today's agenda, sir. What is that? What is that? I said we're going to talk about differentiation in ITF, logarithmic functions. What is ITF? Inverse trigonometric function, logarithmic function and exponential function, right? And we'll take questions on all of these categories with the application of general theorems, right, sir? Yes, sir. Okay. Derivative of inverse trigonometric function. So again, we have how many inverse trigonometric function? Sir, that's very simple. 6. There are 6 trigonometric functions, so there are 6 inverse trigonometric functions. We have already covered that in our chapter, right? In the PU chapter of ITF. Okay. One more thing, for if you remember this, if I've forgotten to recap this, differentiability is only applied where bacha or valid where bacha in the functions domain. Whatever is the function, no, it's applicable only in the functions domain. You don't go out of the domain and say, sir, you said the function is differentiable, sir, and then how it's not coming differentiable. Okay, don't take any point, you know, in the for x and say it's not differentiable. Only you check for domain. In the domain, if it's differentiable, the function is differentiable. That's all. Okay. Okay. So see, the domains are written on this side. -1 to 1 and -1 to 1 for sine inverse and cos inverse. Real and real for tan inverse and cot inverse. And this -1, -infinity to -1 and 1 to infinity. -infinity to -1 and 1 to infinity for sec inverse and cosec inverse. Okay, simple, not a confusing one, very simple, right? I've arranged it in this order so that it's going to be simple for you to understand. Okay, if you want to have a relation, how can this be remember like this? See, remember, these are complementary. If you take the trigonometric ratios, they are complementary, right? Sine and cos are complementary. I'm not saying sine inverse and cos inverse. I'm saying sine and cos, the trigonometric ratios are complementary. Okay, so in that order I've taken. Okay, tan, cot, sec, cosec. Okay, this is simple. Let's see what is the formula. So for the first one, for sine inverse, what is there, bacha? 1 upon root of 1 minus x square. Root of 1 minus x square. So if I have this, the sine inverse is operating on which variable? Variable x. So that variable will be coming in the root like this, 1 minus x square. What about cos inverse? Simply a minus sign will be added. Simply a, check here, only minus sign is added. All right, so please check. Okay. In the case of tan inverse, what happens? 1 upon 1 plus x square. I know most of us remember this formula, 1 upon 1 plus x square. Why, sir? Because this has been asked in multiple occasions. All the questions, I don't know why they prefer tan inverse, but yes, they do. Okay, tan inverse questions are asked. I think in today's session also I've taken a question where tan inverse is asked. In boards or any competitive exam if you're writing, obviously this will be, I don't know why they prefer it, but they do prefer it. Okay, so tan inverse is 1 upon 1 plus x square for all x real. Again for cot inverse, just add a negative sign, minus 1 upon 1 plus x square for all real x. Okay, for sec inverse x, sir, 1 upon x times 1 upon mod x times, only positive value will take, x square minus 1. Again the domain is -infinity to -1, 1 to infinity, union 1 to infinity. For cosec inverse, what will do, bacha? Again just add -1 and the mod of x we can consider. All right, so okay, so simple formulas are there. If you see, they're related to each other, so not difficult to memorize. For sine and cos, there's a root existing with a negative sign. For tan and cot, there's no root with positive signs in the denominator. For sec and cosec, there exist, but in inverted way, x square minus 1 is there, but what is it? X is also outside. So if you want easier to make a pattern out of it, to make sure that you are memorizing it. Sir, is memorizing necessary? Yes, very necessary, because bacha, your exam is based like this, right? 60 minutes, 60 questions. If you have to solve that many questions in 60 minutes, you cannot have this liberty to recall the formula. It has to be on your lips. If the question comes, what's the tan inverse differentiation? 1 upon 1 plus x square. What's the cosec inverse differentiation? Minus 1 upon x times of x square minus 1 in the root. Okay, you have to know this by heart. Okay, you cannot wait for it to come. You cannot, because if you are waiting, you might in the hurry, you might take some other formula and make that silly mistake and lose marks. So make sure that you should not compromise at all with formulas. Wherever are the formulas, you must know it by heart. Okay, doesn't matter whatever you think, just you have to know all the formulas by heart. No ifs, no buts. Okay, sir, this is better way. Whatever is the better way for you, but formulas is the first priority. You must know the formula, you must know the concepts. Very plain and simple. Okay, all right, let's move on to the next slide. What is it? First question based upon this concept. Okay, Okay, the first question itself is a very good question. The first question itself is a very good question. Check here. So y equals to cos inverse of 2x upon 1 plus x square is there. 1 plus x square is there. So if you remember, a formula is there, bacha. If I take a substitution, okay, I can take this substitution, right? Yes, sir. Let's see. Actually, few of the students, many students might be able to answer this once I write this substitution. X equals to tan theta, sir. X equals to tan theta. If I do that, what will happen to this function? Please check. It will become this part of writing, only this bracket part. It will become 2 tan theta upon 1 plus what, bacha? Tan square theta. Tan square theta. What is this? This is the domain, okay? The x value is ranging from -1 to 1, okay? Alright. 1 plus tan square theta. What is that? If you remember, this is nothing but sine 2 theta, right? The formula of sine 2 theta in terms of tan was given by 2 tan theta upon 1 plus tan square theta. Yes, sir. So this is the formula. Again, I said, very important to know all the formulas. Wherever it is, you should know it. You must know it, okay? Alright, then I can replace this thing in the bracket by what, bacha? By sine 2 theta. Please check here. Please check here. Okay. Sir, but what happened? Even if I replace it, there's not much different. We cannot operate cos inverse on sine. What's the importance of this? I can move ahead and write sine in terms of cos, because sine and cos are complementary function. Remember, I can write this as, please forgive me, I wrote sine, I wanted to write cos. So cos of pi by 2 minus 2 theta. Now remember, cos 90 minus theta is how much? Cos of, please remember this formula, cos 90 minus a. How much is that? Simply sine a. So that's what I've written here. Operate it now. What will this become? Simply pi by 2 minus 2 theta. Correct? Cos inverse of cos will be just the theta. Cos inverse of cos inverse will be pi by 2 minus 2 theta. Okay, sir. This is done. This is done. Now, are they asking this only? Are they asking us this only? No, sir. What are they asking? Please check. They're asking us to differentiate. Asking us to differentiate with respect to x. So there is no x here. How will I differentiate? Yes, this is the function y, but there is no x here. Let me write the function here. Y equals to pi by 2 minus 2 theta. So there is no x here. Is it? Is it? I cannot write this as. Please check. Please check here, bacha. If x is tan theta, which means that I can rewrite this as tan inverse of x equals to theta. No doubt in this, right? No doubt in this. Please check. Yes, sir. Theta is tan inverse of x. Okay. Now I can differentiate, sir. Now I can differentiate, sir. How will I differentiate? So dy by dx equals to, this is 0, sir. Constant will be 0, right? Differentiation of a constant is a 0. Again, I can take this 2 outside and take what? Derivative of this. Yes, sir. This is minus 2. How much is that? Tan inverse differentiation. We just learned 1 upon 1 plus x square. My final answer of dy by dx is what, bacha? Is minus 2 upon 1 plus x square. This is my final answer. This is my final answer, right? Simple question, but you had to use the substitution of this formula for compound angle. Okay, let's move on. Okay, now coming to the exponential functions. I said no, we have ITF. Again, don't worry, I have not taken only one question on inverse trigonometric function. We'll have more coming in, okay? And if you want me to do more questions of ITF, comment below. Let me know that yes, sir, I am struggling in ITF. Please solve more and more questions in ITF. I'll come up with a session in which I will include more questions in inverse trigonometric functions. So comment below if you have a need. Make sure that you are always interacted and connected with me. Okay, exponential function. What is it? So obviously we have seen exponential functions, right? Sir, whenever I hear this word exponential function, no, I only know this. That's what we have learned, sir. In 10th also we used to know sometimes when I was very eager to learn some advanced concepts. I used to know this, that exponential function was e power x. It's not there in 10th grade, but still some students have this ability or this this thirst of knowing something extra, right? Few students have this, so they'll also know this. Exponential means this, but actually exponential means what? Standard form is a constant base with a variable power. Constant base with a variable as power. Please check here. The function of the form y equal to fx, where x is what? In the exponent. Please check here. Variable exponent and a constant base, right? Provided a is not equal to 1, okay? Why not 1? Because if it is equal to 1, then what will happen? It will become a straight line, no? Please check. If a is equal to 1, sir, what will happen? A to power anything will be what, bacha? 1 only, no? Y equal to 1 is what? Y equal to 1 is a straight line parallel to x-axis. Correct? So we cannot take that. We cannot take that. A should not be equal to 1. It's not part of our, relevant concept. I just explained you to why we are not taking a as 1. Okay. So a cannot be equal to 1 and a is always greater than 0. A is always greater than 0. And then what happens? So yeah, the same thing is there. That's the definition of exponential function. So provided what? What are the conditions? Excuse me. A should not be equal to 1. A should be positive. The base is constant and the exponent is variable. That's how we define the exponential function, right? Now what next? If I have the base as e, then I call the function to be natural exponential function. Natural exponential function. And for other things, okay, if I have this as 10, the base is 10, I call it as common exponential function. Common exponential function. It means if I have an example of 10 power x, okay, common exponential function. Let's see some features in the graph. Have you seen this graph? Right, sir, multiple times. Okay, now what happens here, if you remember, this is a graph of exponential function when the a is less than 1 but greater than 0. Sir, but you said a should not be 1. It's not 1. A is not 1. A is less than 1. Please check here. Here also a is not equal to 1, bacha. It's less than 1 but greater than 0. Less than 1 but greater than 0. And I said no, a must be positive. A must be positive. So even over here, a is positive. The base is positive. The graph goes like this. What it means? Means as I approach x to infinity, if I approach my x coordinate, if I approach x to infinity, my y approaches what, bacha? 0. My y approaches 0. There is no negative y. There is no negative y. It means what? It means, sir, range is only positive real number. Sir, you only said no. There is no negative y. Means range is only positive real number. Whereas in domain, we have all real. Correct, sir? All negative also is there. All positive also is there. So all negative positive together means what? All domain. Okay, even 0 is there. See, at point 0, the graph is passing from 0, 1, right? The point, the exponential function will always pass from, what do you call? 0, 1, right? 0, 1. Okay, sir. Okay, sir. All right. Why is that? Any answer for this? Yes, no? Y to the power, if I am writing anything to the power 0, what is the answer? Simply 1, no? That's the function, right? Y equal to a power x. If I write x as 0, answer is simply 1. So exponential function will always, the graph of the exponential function will always pass through the point 0, 1. I hope you understand this. Very simple, right? Always passes through the point 0, 1, sir. Okay. Now they're saying that for very large negative value of the function, okay, for a very large negative value of x, the exponential function, okay. This might be confusing for few people because, sir, the graph is shown something different and we are reading something different. Read here, bacha. For very large negative value of x, the exponential function gets very close to x-axis. Sir, but in the graph that you have shown here, for very large negative value, the graph is moving away from x-axis, not coming very close. Then how you are saying this? Okay, how are you saying this? Please check. Please check. There is an important part missed here. There is an important part missed here, which is a greater than 0. Okay, this is not the graph for a greater than 0. How will the graph of a greater than 0 look like? Please see. This is my x-axis and y-axis. For a greater than 0, for a greater than, sorry, not 0, greater than 1, the graph will be this, bacha. The graph will be this, sir. The graph will be this, sir. Where this, what is this point? Again, 0, 1. Okay. this is the function of the exponential, this is the graph of the exponential function when a is lying between 0 and 1, okay? Whereas when we take a as greater than 1, the function's graph changes to this form, Now you can see, please read this. For a very large negative value of x, when x is moving to infinity, very large negative value means minus infinity of x, okay, of x, y comes, the exponential functions comes close to x-axis, coming close to x-axis but never meeting it. Basically what it means is when x tends to minus infinity, the y will tend to 0, it will not be equal to 0. We know that tending meaning, right? We have learned in the limits. So it will not be equal to 0, whether it will tend to 0. I hope this is clear, okay? So yes, I have discussed all the points. This is the graph. I hope there is no confusion here, right? If there is, comment in the section saying that, sir, this part was not clear. I would like to know what is the reason it is not clear, okay? Let's see. Now coming to the, family of, so actually exponential function and logarithmic function are very related to each other. How we'll see. Similarly, you remember trigonometric function and inverse trigonometric function are related, right? We used to find inverse of one and we used to get the other. Same way, there's a relation for logarithmic and exponential also. We'll see right now. So if I have an exponential function given in this format, just forgive me for 1 second. Let me change the color of the ink. Okay, so if I have exponential function given in this format, a power x is given equal to b. And if I apply log, again this condition is valid, a greater than 1. Okay, a greater than 1. If I have what bacha? If I take logarithmic on both sides, if I take logs on both sides, then this will transform into what, sir? Log with what, bacha? With the same base a. So this will transform into log with the same base a to the b equals to x. See here, same thing is written here also. Log of b with the base a. Now if you want to ask how, I can tell you now also. Okay, since you know this, I know you have learned this in PU1, so let's recall it quickly. Okay, when you learn function, you must have learned logarithmic function also. So let's recall it. If I apply log on both sides, how will this look like? Log with the base a I am applying on both sides. So a power x is there, bacha. This is going to be log of b with the base a. This x will come in front, right? So this will transform into x log a with the base a equals to log b with the base a. I know everyone knows by now this is nothing but 1, always 1. Log of same number with the same base is always 1. So this becomes what? This becomes 1. So same, I'll have what left in the LHS side? Only x. So I get what? X equals to this value. I get x equals to this value, sir. Very, very simple. And if you remember, that's what I wrote here. Same thing. Log of b with the base a is equals to x. Log of b with the base a is equal to x. Again, we will see this property today in the session. I have taken a slide where I have discussed all the properties of logarithmics. Okay, so let's see. So yes. So how will you remember this? How to transform an exponential function to a given exponential function to a logarithmic function? Just remember here. Just see here. Whatever is the base of exponent, same base will come for logarithmic also. See, same base will come for logarithm also. And whatever is the value of b, that whatever the equal value was on that side will become for log. Log will operate on that value, and this x over here will become free. So subject, remember. So basically, subject will change itself. What is subject here? If for this equation, what is subject here? Subject is b. Subject will become x. Okay. Here x was on the power, so log will be operating on that value. So you can remember this. Base will be base, and subject will interchange. I hope this is clear. Okay. This is my way of remembering this. You can find it another way. If you want, you can stick to this method also. Okay, because there are questions where you have to apply exponential on logs or log and exponential to get the result or to solve your complex mathematical problems, sir. Okay, now please check here. Defined on what, bacha? R plus 2r. R plus 2r means the domain is now only positive real numbers and range is now real. Remember in the previous case, the domain was all real and range was r plus. Now from here only you can say, sir, it is inverse. Correct? Because remember, what used to happen in inverse? Inverse was domain becomes range and range becomes equal to domain. Range become equal to domain. Yes, sir. Okay. So the domain and range are interchanged. All right. Anything else? If I take the base to be, if this base is 10, then we call it as common logarithms. If this base is e, natural value, we call it as natural log, written as what, bacha? Ln, written as ln, natural log, right? So we write the symbol as ln. Okay. Let's look at the features. Okay, this is a graph for a greater than 1. If I write between 0 and 1, what will happen? The graph will again come like this. If you remember, I cannot write here like this. The color is not visible, sir. The color is not visible, sir. I can draw this graph like this. Okay, I'll show you. I can draw it separately also. Okay, so if you remember this, in the previous case we had this point, no, 0, 1. All the exponential function must pass from which point? 0, 1. In this case it is just, the x and y coordinates are reversed. It becomes 1, 0. Why? If you want to ask me why, I think you know this property. Log of a to the any base, how much is that? Log of 1 to any base, how much is that? Always 0, sir. Always 0. So obviously if you replace x by 1, answer would be, y value will be 0. So any logarithmic function, if you draw the graph, it will pass through, it must pass through the coordinate 1, 0, sir. Yes, sir. That's very, very simple, sir. Okay. Domain is what, bacha? I already discussed, r plus and r. I said exponential and domain, exponentials, domain and range gets interchanged here because the graph is inverse. This I said always pass through 0, 1. Okay. For x very close to, now again this I don't have to delay, right? I can draw from here only. For this particular, I can just draw it over here only. For x tends to whatever, bacha. When x tends to infinity, y tends to infinity. Please check, x going to infinity, y tends to infinity. When x tends to 0, y tends to what? Negative of infinity, right? Y tends to negative. For x very close to 0, the graph of logarithmic function gets very close to y axis. Okay, so over here what is happening? Please check here. When x is 0, y is going very, very close to y axis, but never 0. If I have to draw the other part, when a is between 0 and 1, this is going to be my graph. There is no negative side. This is not part of the domain. I will not go left of the y-axis. There is no negative x-axis. There is no negative x. See, domain is r plus. There is no negative x. So graph will go from. Okay, this was already drawn. This is already drawn. I have to draw the reverse one, right, sir? Sorry, sir, for making this mistake. This is it. This is your log graph for a value lying between 0 and 1. Lying between 0 and 1, sir. Okay, again, what is this point, bacha? 1, 0, sir. Okay, again, if you check here, when I take this x very, very close to 0, I am moving towards left from this point, very, very close to 0. What is happening to the y, to the curve? Curve is getting very close to y-axis, but not actually becoming 0 at any point. Not becoming 0. Y can never be 0. Y can never be 0. Logarithmic. Y cannot be 0. Y is 0 at only one point, which is, forgive me, which is x equals to 1. My bad. Y is 0 only when x is equals to 1, sir. Okay. Alright. Again, this is same thing. For any inverse, what we do? For any inverse, we take the mirror image about this line. Correct? No? No? Yes? 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 You want me to show you? You want me to show you? Let's see. I hope you have seen the graph. Okay, the other one, if you want me to draw it, I can draw it over here only. Let's see. I want to draw it. This is how it will go. Okay, this is when a is between 0 and 1. A is between 0 and 1. I want to show you the other graph. Okay, I want to show you the other graph. How can I take the mirror image and get the same function? Let's see the exponential. Exponential function. This is my y equal to x line. How will the mirror image look like? Please check. This, sir. This only, no? Please check. Okay. Only negative. This negative x will become what, bacha? Negative y. Please check. Negative x will become negative y. Okay. This will be the same part. So if I take this line, this is my y equal to x line, this is my y equal to log x, okay, and this is my y equal to a power x. A power x, y equal to log x and y equal to a power x are inverse to each other, and they are symmetric about which line? They are the basically mirror image about which line? Y equal to x line, y equal to x line. I hope this is clear. Can I move on to the next part? Features we have discussed. Okay sir, now some properties of logarithm, very simple. I know all of you might know it already, but let me revise it anyway. Okay, so we know product rule for logarithms. If I have log operating on product of two numbers, I can take simply log of one number plus log of two numbers, the second number, and we'll get the same answer. Again the domain part is coming to picture. Both values will be greater than 0 and not equal to 1. Okay, the base cannot be equal to 1. Okay, over here please check, this is base change formula, right? Please check what is the base here. A, base is A. What's the base here? E. What's the base here? E. Sorry, A and E. So what happens, you can just check here, E and E should be same. Okay, I can rewrite this log A, log x to the base A in terms of any base. If I have, let's say, log of 25 to 50 with the base what? 3. Okay, I can write with any base like this, log of 3 to 50, log of 250, okay, and what? Okay, no, my bad. I can write here log 7 250, or if you want I can go ahead and write one more step. Please check, log, let's say I write 17, log 17 to the base 250. I can keep going on like this. Please check here the base change formula. It works like this. Yes, 17. The end result will be this log, the base, and this will be the value where the log is applied. Log of 250. You can simply combine this. If the change is given like this, if you have given log as product like this, and the bases are in this form, the base and the value, then simply take the last value with the first base, and the answer will become simply what? Log of 250 to the base 3. Same thing is written here. Okay, I hope you understand this. Okay, base change formula. Next, what? This is not cancellation. This is just I'm trying to explain you how the bases are interchanged here. Base and the values are interchanged here. Okay, sir. Okay, again the conditions remain same. A not equal to 0 and x greater than 0. A not equal to 0 and x greater than 0, sir. Okay, moving on. This is what? This was the product. This was the quotient. This is product. This quotient. If I have to apply log on ratio or quotient of two numbers, I can simply take log of first number minus log of second number. Again the boundary conditions remains same, and greater than 0 and greater than 0, a greater than 0 and a not equal to 1, sir. Okay, this is a missing part here, not m, this is n simply. This is n na, right sir? I use it right now. Log of exponential power, okay, means I have m to the power n, m to the exponent n. I can simply take n out here like this. So see, n comes here out, n times of log a, so log of m to the base a. Okay, if I have, basically if I want to write this example, is if I have 5 to the power x with the base what? Let's say 2. I can simply rewrite this as x log 5 to the base 2. X logs 5 to the base 2 means this x will come out and become multiple. Okay, will become multiplied with the logarithmic expression. Okay, all right, so this is clear. Okay, let me see the last part. E log e power x, e log x to the base e. When this is there, see, exponential and log, what is it? They're inverse operator, no? Remember cos and cos inverse, cos and cos inverse, or cos inverse cos. What happens to the result? Whatever is the value here, answer is simply x. Cos inverse of cos is simply x. Same way, e log e will be what, bacha? E and log e, e and log r, inverse functions. So if I am operating at the same time, one to another, I will simply get what answer? As x. Okay, I hope this is clear. No doubt here so far. Correct, sir. Moving on. Okay, Yes, log of x to the base a. This is what we can do. Again, we can write with a common base. So if I have to take example of this, I can write this log. Let's say I've written here 150 to the base 2. 150 to the base 2. I can simply write this as both as log of 150 to base x some value and log of 2 to the base x. Means with the same base I can write this log in the ratio. Same base I can write this log in the ratio. Okay. See, the base is, I have not written the base here, but you can see the base from here. So same base x and x. I can take x as anything, 2, 3, 5, 4, any value. Okay. Must make sure that the base is same for both numerator and denominator. Alright. Okay. Again, log of m to the base n. M to the base n is simply reciprocal of log of n to the base m. So basically what is happening here? M and n are interchanging its value. Please check here. N becomes m, m becomes m. So here n was the base, here m is the base. Okay. Next, log of 10 to 10, 1. Log of e to e, 1. Log of any value to itself. So log of simply a to a is always 1. Okay. Again, a should not be equal to 1. Log of 1 is 0. This we know that, we just discussed it. Log operating on 1 with any base is equal to 0 provided the base is not 1. Okay. Some people might have this thing. Sir, log, you said log of a to the base a is 1. So take now log of 1 to 1 is simply 1. Sir, log of 1 to 1, correct. Log formula of a to a is 1. So log of 1 to 1 is 1. Okay. So how are you saying the base cannot be equal to 1? I have taken example. Some students might come up with this, have this thought. So I have taken example, sir, of log where the base is 1. Value is of the log value that we are finding, the x value is 1. Answer is 1, sir. So log exists. The log exists, sir. No. Incorrect. When the base is 1, the logarithmic function does not exist. Does not exist. Don't give this reason. This is incorrect form. Okay. Log of a to base a is 1 provided this a is not equal to 1. For any value other than 1, it will be equal. Again, positive also. Positive also. See here, positive also. It cannot be negative. The base cannot be negative as well. Okay, sir. Now differentiation if I are taking. So with this, learn this. Whatever in the log will come in the denominator, right? Log of x was 1 by, I taught you this. Differentiation of log x. What was that? Was simply 1 by x, right? If it is log of f of x, then f of x will come down. F of x will come down. What's next? Again, the chain rule will apply. I have to take the derivative of fx also. Correct? The chain rule will apply, no? Log differentiation is 1 by fx, but fx differentiation is what? F dash of x. F dash of x. Yes, sir. Same way goes for exponential function. E power x will remain same as e power x or e power fx, and then again I have a differentiation of fx. Okay, chain rule will apply over there also. Okay, e power a, if I have a power fx, it will remain same with ln a will come. I taught you this yesterday also. A power x, what is the differentiation? Ln a power x. Ln a power x. So log a, then again this is the differentiation of the function df by dx. Okay, simple things, right? Let's quickly move on to the questions. Okay, I told you the inverse part will come. I have taken questions on inverse also. Now second question, what it says, please read the question. It says differentiate with respect to x. Okay, it's x only, the variable is x only, no problem there. For this function, sine operating on tan inverse of e inverse of x. Sorry, yeah, e power minus x, not e inverse, e power minus x. Please forgive me for saying e inverse. Okay, all right, let me solve it now. So basically if I take this, y equals to sine tan inverse of e power minus x. What I'm going to get, bacha? If I'm writing dy by dx, dy by dx will be given by what, bacha? First I will operate on sine. Obviously I can use what rule here? Please tell me. Can I use the product rule here? No, sir. There's no two different function. It's function operating on another function. There's no two different function. I don't have fx into gx. I have function operating on another function. Okay. So I will use what rule here? Chain rule. Means first I will go for sine function, then I will differentiate the tan inverse function, then I will differentiate the e power minus x. Okay. So I will differentiate the function after one after another. So chain rule I will use. Please check. For sine I will get what, bacha? Cos of Don't ask why. Whatever is sine operating on, that will come as it is, no? The cosine function is differentiated. Next what will come? Tan function. Next what will come? Tan function. What is it going to be? Tan inverse differentiation. If you want, I can write it here. Differentiation of tan inverse of e power minus x. Is it over, sir? No, bacha. What last will come? Looks like x, sir. Okay. So let me write this form only. I'll write simply as multiplication again. So multiplication with what? Differentiation of e power minus x. Differentiation of, so I'll write it over here only. Differentiation of e power minus x with what? The base is always dx, because they have given with respect to x. Let's continue with this. So dy by dx will be nothing but, so this will remain as it is because already differentiated. So cos of tan inverse of e power x. What's the differentiation of tan inverse? 1 upon x square. So I write it as 1 upon what, bacha? X square. What is x here? E power minus x is the whole thing, right? So 1 upon e power minus x the whole square. Yes. What about this? The last part, e power minus x differentiation remains as it is. And what is the last one? I can write here chain rule for minus x also, which is going to be minus 1. Correct, right? E power minus x differentiation will be e power minus x, then I have to differentiate what? Minus x also, no? So it will become minus 1. Okay? I hope there is no confusion in that part. I have to differentiate till the last function. Last function is what? So check here. I did not mention it in the beginning. Trigonometric, inverse trigonometric, exponential, then linear. Please check order. Trigonometric, sine. Inverse trigonometric, tan inverse. Exponential, e. And x is also a linear function, minus x. So I have to take for that also. The differentiation of minus x is how much? Simply minus 1. Okay, simply minus 1. Okay, cos of tan inverse of e power minus x will be written as it is. So if I take the minus sign out, I can write it as minus e power minus x. Okay, and then I'll go write the cos part. So cos tan inverse of e power minus x upon 1 plus e power minus 2x. Please don't ask how it is e power minus 2x. We are using what? Exponential functions rule, right? Power rule we are using. E power, this 2 will come inside. 2 will multiply with minus x, will become minus 2x. Okay? This is the final answer. This is my final answer, bacha. For y dash or dy by dx. Y dash or dy by dx. What is this? Minus e power minus x cos of tan inverse of e power minus x 1 plus e power minus 2x. E power minus 2x. Moving on to the next problem. I can move to the next problem, right, sir? Yes. Question number 3. E power x plus e power x square plus e power x5. So how many terms are there? 5 terms. 1, 2, 3, 4, 5 terms. Correct? Again differentiate with respect to x. Is it a difficult question? Sir, looks difficult. Looks difficult, but it's actually very, very easy. Very, very easy. Let's see. Right here. Y equals to e power x plus e power x power 2 plus e power x to the power 3 plus e power x to the power 4 plus e power x to the power 5. We know that in differentiation we can separate the differentiation for each term. So if I differentiate this y, I can take for them together, or I can take the differentiation for each term. Am I right? Yes, sir. Let's see. So I'll write y dash as, what is y dash? Simply dy by dx. Dy by dx is given as y dash. Okay. Y dash is equals to differentiation of this. Same way I can write for others. Others also. Again for this also. And for the last one also. Correct? D of e power x power 5 upon dx. How will this look like, bacha? Please check. So simply this will be e power x, because differentiation of e power x is e power x. What about this? Differentiation of e power x square will be e power x square only, but chain rule will apply, because first exponential then what? First exponential then what? Then is quadratic. So I'll write it as or polynomial. So simply 2x. Simply 2x. What about the next one? E power x power 3, then 3x square. What about next one? E power x power 4, then 4x cube. What about next one? E power x power 5 and 5x4. Don't ask me how. For this part here, this part here, this part here, and this part here, what I've done is I've applied this formula. D differentiation of x power n is given by nx n minus 1. So 2 into x power 2 minus 1 is 2x, 3 into 3 minus 1 is 2, 4 into x power 4 minus 1 is 3, 5 into x power 5 minus 1 is 4. Okay, so what is my final answer? Please check. This is my final answer. That's my final answer. Okay, I hope this is clear. Moving on. Differentiate cos x upon log x, provided x is greater than 0. Why, sir? X is operated by log, right? For x, for cos, I can take what? Any angle, so all real. But for log x, x will not be negative also. So I have to apply the condition for what, bacha? Condition for positive thing, because in case of log we don't have, remember, we don't have, the domain of log is what? Only positive real numbers. Okay. So what we have to apply? Can you see from here? We have to apply here what? We have to apply here quotient rule. Let's check here quotient rule. So first write here y equals to cos x. We can write like this, right? लिख लेंगे cos x upon log x. Cos x upon log x. So how will the quotient rule look like? Do you remember? Y dash is given by first differentiation of the first one. So write log as it is, and then write differentiation of the first one as this d by dx of cos x, then comes a minus sign, then what you're gonna do? Keep the cos as it is, and then what do you do? Differentiation of log x upon, differentiation of log x and whole thing divided by log x, or the function denominator the whole square, right? Right, sir? Not visible, please check. Y dash equals to, what's the differentiation of cos x? What's the differentiation of cos x? Minus sin x. So I'll write it as log x times minus sin x. Okay, what about this? Simply minus cos x. What about this? Differentiation of log x. Differentiation of log x. How much is that? 1 upon x. 1 upon x. How much is that? Please check. Log x the whole square. Can we simplify it? Yes, I can. I can take the x as LCM. So this will become what? Y dash is equals to x log x sin x. I'm taking minus sign over here. This minus I'm taking over here. I'm writing log x sin x. Okay. What about here? Minus cos x is not alpha, it's x only. I hope you understand, this is x only. This is not alpha. That's x only, sir. So cos x divided by, I will have this x in denominator, so I can simply take here. That's your answer. That's your final answer. Okay, that's your final answer. Y dash minus x log x sin x minus cos x upon x log x the whole square. X log x the whole square, sir. Simple? Yes, sir. Very simple. Okay. Moving on to this problem. Again, log with exponential function is there. Log with exponential function. Let's see how will this work. Okay. I think this is very, very simple. Y equal to, if I take log e power mx minus e power minus mx, right, bacha? Right, that's what the question is given. Take the y dash. Y dash will be what, bacha? This will be, first I will take differentiation of, again what I'm going to do, I have to use here first chain rule, then I will have to use what do you call, product rule. No product rule, only chain rule I can use. Okay, there is no use of product rule. So I will use this as e power mx minus e power minus mx, correct? Log whatever is inside will come down, right? Log of x, differentiation is 1 by x, so like this, e power minus mx, this is there. Now I have to take what? chain rule, differentiate this also. If I differentiate this, how will I write this? D by dx of e power mx, minus sign will come because I can separate the differentiation. Again what I'll write? D by dx of e power minus x. Yes or no? Yes or no? Yes sir. Yes sir, of course sir. Yes sir, of course sir. How much is this sir? Simple question sir. How much is this bacha? This is e power mx. E power mx times what? M. M will come, right? If you differentiate e power mx, I'll get e power mx, but mx also if you differentiate, you'll get m. How? Please solve it. Please solve it. If you have this doubt also, ask me. Okay, I don't think you will have this doubt that how this e power mx is coming as m times of e power mx. Same way I'll get what here? E power mx multiplied here what? With minus m. With minus m. I can take m common here. Please check here. I can take m common. So I get m here. If I do that, what I'm going to leave here? E power mx. This minus and this minus will become plus. This minus and this minus will become plus. Then in multiplication, so plus. What is this? E power minus mx. Okay. Whole thing divided by this denominator. E power mx minus e power minus mx. Okay. This is my y dash. Some students will do this. So cancel each other. Right? Incorrect. We are very eager to cancel. Do not do that. Please check. It's not the same. Please check. It's not the same. Here plus, here is minus. Terms are same, but operation is different. Plus and minus. We can't change that. So what is my final answer? This only, sir. This is my final answer. Y dash equals to m times of e power mx plus e power minus mx upon e power mx minus e power minus mx. E power minus mx. Okay. Moving on to the next problem. Okay. Yes, I will have to use the product rule here. Please check. E power x is acting with log. So e power x is different function. Log of this is different function. So I have to use what? I have to use the product rule of course here, sir. Let's check how will I solve this, sir. Please check this. Okay. So let's write the function first. Y equals to e power x log of sine 2x. Correct? Differentiate with respect to x only. Okay, excuse me. I said what? Use the product rule first. For this you can use first function this, second function this. Then I will use what? Chain rule. So what will this be? Y dash equals to, first I'll differentiate this e power x. So what will this be? Or let me keep this. I'll differentiate this part first. So I'll keep this as e power x as it is and take differentiation of this bacha. Differentiation of what, sir? Log of sine 2x. Look, sine 2 alpha, sir. Let me write it bigger. Sine 2x. Sine 2x. Log of sine 2x. Then plus sign will come. Correct? Product rule plus sign is there. And then I'll keep what? Log of sine 2x as it is. And differentiate what? E power x. Differentiate e power x. Check for the result. Please check for the result. How much I'll get? So I'll get y dash. I can erase this. I can write over here only. I'll get y dash equals to, please check, e power x will remain as it is. And this will be what? Differentiation of log. How much is that? 1 upon the value in the log. So 1 upon sine 2x. Is that over, sir? No. Chain rule will apply now. What is that going to be? Differentiation of what? Sine 2x. How much will that be? Cos 2x, sir. Cos 2x. Is that over, sir? No. Again, what I have to do? Chain rule of 2x. See, first log, then trigonometric, then what? 2x is a linear function. So what will that be? That will be simply 2. That will be simply 2. What about this plus sign? This will be coming as log sine 2x. Log sine 2x. And this will be, what is the differentiation of e power x? Same as e power x. Same as e power x. I can see e power x. E power x is common. So let's take it common. So y dash equals to e power x is common. What's that? Cos 2x sine 2x with the value 2. So write 2 first. Cos by sine. Cot 2x with the plus sign. I have taken exponential function out. So log of sine 2x. Check an answer like this. E power x 2 cot 2x log of sine 2x. E power x. Check. Simple. Easy. Extremely easy, sir. Okay. We had to use what? First the product rule. Then we use what? Chain rule for the first differentiation. For the log of sine 2x we use the chain rule. First we took for log. It came as 1 by sine 2x, then we took for sine 2x, came as cos 2x, then we did for 2x, which came as 2. I can move on to the next problem. Let's see. So, yes, this is the final answer. We already summarized it, sir. Okay. We had the option, right? We don't have to do this thing. Alright. Okay. Now, we are looking for logarithmic differentiation. We are looking for logarithmic differentiation, sir. Okay, means we have learned what is a logarithmic function. Okay, but how can I differentiate logarithmic function if it is given in the terms of functions only? Let's check. This is a function given like this. So if a function involves product, quotient or power of 2, means if I have this forms present here, product is present, quotient is present and power is present, I can simply apply log on both sides. I don't have to answer why, because if I have power, quotient, product, I have these rules, right, in logarithms. Log of product we have, product rule we have, quotient rule we have, power rule also we have. So for all these names this is written here, product, quotient and powers, we have rule in logarithms. In that case, I can actually simplify this much easier. Okay, so that's why, so see, example is taken in the case of power rule. Y equals to fx to the power gx. If you apply log on both sides with the same base, what will happen? This will be log y. What will happen to this thing? It will become, what will this become? Please check here. It will become log of fx to the power gx, and this gx will come in front like this, gx log fx, sir. I don't need this, gx log fx, sir. Okay. So this gx, if you take log, will come in front. The power rule is there. Okay. Now, if I have to differentiate this on both sides, how will this look like, bacha? Please check. Which will I differentiate? Obviously this part. Please check how will this look like. 1 by y. Log differentiation is what? 1 by y. Again, y is not there, so I have to do dy by dx. Correct? Equal to, what will this be? Product rule have to apply, right? Product rule have to apply. First, let's do for, I'll do for gx first, or I'll keep gx as it is. So I'll keep gx as it is. I'll do differentiation of log of fx. Then I'll do what? Plus. Keep log fx as it is, log fx as it is, and do differentiation of what, bacha? Gx. Differentiation of gx. Correct? How will, if you ask, can you simplify this? Yes, I can simplify this, sir. This will become simply gx, and what will this be? Log of anything taking differentiation, what will happen? Please tell me. It will come in denominator, no? So 1 upon fx, sir. 1 upon fx, sir. Yes. Is it over? No, sir. Log is differentiated, but what about function inside? I have to differentiate that also using what rule? Chain rule. That will become what, bacha? F dash of x. Differentiation of f is what? F dash, right? We learned this, the notation, how we represent a differentiation. This is not an actual function here, just a symbol. So I'll take it as f dash x and understand it as differentiation. Take it as f dash x and understand it as differentiation. I hope this is clear. Log fx will remain as it is. How will this be? Tell me. This will be g dash of x. G dash of x, yes or no? Please check. G dash of x. How much can I rewrite this? Final answer. So I write only this part. What will this be? Dy by dx is equal to, I can take this y on that side. It will become y times of, in the bracket, gx by fx. This is what, bacha? Gx by fx. I hope this is visible. Yes. Gx by fx is visible, right? Is g not visible? Let me write again. Gx by fx now visible? Yes, sir. Okay. What next? F dash of x plus sign will come. This part I can write log of f of x, then g dash of x, correct? This is the way I can, if you don't want to, you can, if you want, if a function is given in this form, you can use this directly and get your result. Use this directly to get your result for differentiation. But why I'm trying to do this? I'm not trying to complicate you. I'm trying to do this because I want to show you that for the same form, if I use logarithm form or even if you use exponential form, I get the same result. So for the logarithmic form, I got this result. Please check. This is my result, right? This is my result. For the exponential form, what I'll get? Please check. Same expression is taken in exponential form, e power gx log of fx. E power gx log of fx. Can you tell me how is this true? Can you explain me this? I hope everyone is getting this. If not, let me explain it to you. So if, forget about e right now, forget about e. Gx is multiplied to log, right? So I can simply take gx on the power of fx. So what will this become? Log to any base, fx to the power what? Gx. Yes or no? Please check. Yes sir. If I take this like this, I'll get what? I'll get this gx back to the coefficient term only, no? So I can take it like this. If I'm taking like this, effect of e and g will be neglected because they are inverse. So I get final answer as simply f of x to the power g of x. Same thing is written here. So I can rewrite this thing as this. I hope this is clear now. I can rewrite fx to the power gx as e to the power gx times log of fx. E to the power gx times log of fx. I hope this is not a doubt anymore. Okay. Now we will take the differentiation of this expression. What is this expression, sir? Y equal to e to the power gx log of fx. I'll take the differentiation of this expression. Okay, sir. Let's do that. So y dash will be what, bacha? Tell me. So first I will take what for e, then I'll use the chain rule, and then I'll use the product rule also. Okay. First let me use this. So e will remain same. So I'll get what? E power gx and log f of x as it is, right? Because what happens is anything to the power e will first come as it is, then you have to take the differentiation according to chain rule for the power also. Correct? But exponential to whatever is the exponential, let's say I have e power 2005x. Take differentiate it. What will happen? This will come as e power 2005x times 2005. Correct? Now whatever is in the numerator, same in the exponential form, that will come as it is. Then you will differentiate using chain rule. Okay? I hope this is clear. I don't need this. I'll erase this part. Let me continue here. Quickly I'll complete this, then move on to the problems only. This is not a problem. This is explanation that how even if I solve exponential differentiation or logarithmic differentiation for the same given condition, I'll get the same result. Please check. E power gx. So I have done the first part, exponential part. Next part will be what? Chain rule. So for chain rule I have what? Please check. I have two numbers, two functions, this and this. Means I have to apply the product rule. So I'll do what? First I'll take for gx. This will become g dash x. Okay, or let me do the reverse way. I'll keep gx as it is because in the previous one also I kept the gx as it is. So I'll keep gx as it is. Okay, how much is that, bacha? Tell me. And this will take differentiation of log of fx. So I can write directly now. I hope you understand now. I'm going to differentiate what? Log of fx. So simply it will come as 1 upon fx. Correct? And then I have to do the chain rule again for fx. So f dash x will come, bacha. Okay. Now product rule, so plus sign will come. I kept gx as it is. So now this time I'll keep log of fx as it is. And I'll solve what? Differentiation of gx. Please simplify this and please check. What is this value? E power gx to the power log of fx. Simply y, no? E power gx log of fx. Check here. E power gx log of fx. Simply y. I can write it as y. And what is it? G of x upon f of x times what? F dash of x plus what is this? Log of f of x times g dash of x. This is summarized, right? This is my y dash. Please check now. Please check now. Please check. Y times gx by fx, y times gx by fx, f dash x plus log fx times g dash x, log fx times g dash x. So whether I use for the same function y equal to fx to the power gx, when I applied logs on both sides, I got the same result as differentiation, or whether I operated with exponential for the same function, same expression, I got it as same result in differentiation with respect to the same variable. I hope this is clear. I hope this is clear. Okay. All right. Next, let's move on to this problem. Differentiate cos x, cos 2x, cos 3x. All of this is in product, bacha. Cos x times cos 2x times cos 3x. Looks difficult? We don't have to use the compound angle formula. Let's see how. So first, what is the one thing? We take cos y equal to cos x times cos 2x times cos 3x. Okay. Now, if you have, listen to me, if you have heard me right, if you are paying attention, you will know what to do. Please read. If a function involves product, quotient and power, product is there, no? Function involves product of functions. So I can take what simply log on both sides and solve it. How will this look like? Log of what will happen? Same thing will come, the whole bracket. I can write what? Basically, it will be cos x, cos 2x and cos 3x. Okay. This thing can be rewritten as what, bacha? Tell me. Log of cos x plus log of cos 2x plus log of, I am writing as only x. Log cos x, cos 2x and cos 3x will come. Okay. Let me write it over next step only. No problem. This is log y equals to log of cos x plus log of cos 2x plus log of cos 3x. I hope you understand this. No? A into B into C in log, the number in product, I can take in the sum, right? Log A plus log B plus log Z, same thing. Okay. So product rule is applied in the logarithm. So if I take the differentiation, what will this be? Differentiate everything. I'll get what? 1 upon y. This is differentiation. This is differentiation of the expression of this equation. 1 upon y dy by dx. Correct? Log y differentiation 1 upon y dy by dx as it is. What will this be, bacha? Log of cos x will be what? 1 upon cos x. 1 upon cos x. And what about cos x differentiation? Minus sin x. Correct? Same way over here. Plus 1 upon cos 2x. 1 upon cos 2x. And differentiation of cos 2x will be minus sin 2x. Is it over? No, sir. I have to do for 2x also. So 2. What about cos 3x? This part. 1 upon cos 3x. What will this come now? This will be minus sin 3x times 3. Okay. Alright. So what I have got so far, please check here. I have got it as 1 upon y dy by dx. Let me simplify this. I have got minus sin x by cos x. Please check. Minus sin x by cos x. Next I have got it as minus 2 sin 2x by cos 2x. Minus 2 and minus 1. This minus sin. Minus 2 upon sin 2x by cos 2x. Again this will be what? Minus 3 sin 3x by cos 3x. Please check here. Correct. Okay. Now this is, can you simplify this? I'm looking to find the value of dy by dx. I'm going to take the y on the other side. Okay. Take this as bracket. Let's take minus sign common. Minus. Take minus common. Sin x by cos x. How much is that? Tan x. Sin 3x by sin 2x by cos 2x plus tan 2x. What about this? Plus tan 3x plus tan 3x. Okay, sir. Okay, sir. Now put the value of y back in this question. Minus what, bacha? Cos x times cos 2x times cos 3x times this whole thing. Tan x, tan 2x, tan 3x, tan 3x. This is the final answer. This is my final answer. No, this is little lengthier, but even though it's lengthier, it's very simple, right? Lengthier but simple. Okay, please check. Yes, every step is covered. Okay, differentiate with respect to x. Okay, we have to differentiate this part, this function with respect to x. How will I do it? One of the options should be correct. Which option is correct? I don't know. I have to check. I'm not sure. Let's check the answer. So after solving it, let's check. So y equals to sec square x to the power 1 by x is given. You will agree with me. That's what I've written here. I've written in the form of function y equal to x sine sec square of x to the power 1 by x. That's correct. Okay. All right. Then what I can do? Power is there. I can apply log. Simply I can apply log. So log of y is equal to what, bacha? Log of same thing, sec square x to the power 1 by x. Correct. Bring this 1 by x in front. 1 by x log of sec square x. Again I can take this 2 out here. What will this be? 2 by x log of sec x. Secant x. How much is that? Log y. Okay, this is clear. I will differentiate it. So I have to use first what? Product rule for 2 by x and log sec x. Then I have to use what? Chain rule also. So let's check in this slide. What I can write it as? My log y is equal to 2 by x log of secant x. Correct. Okay, this is right. All right. So I did not miss anything. Take the differentiation now. If I do that, what I'm going to get? I'll get here 1 upon y. What will this be, bacha? dy by dx equals to what? I'll say what? First I'll use product rule because two different functions. Here I have 2 by x and I have log. So I can use first, let's keep 2 by x as it is. Let's keep 2 by x as it is. I can do that, and let's do for this one. Differentiation of log of secant x. Okay. Now what next? Okay, this is clear. What next? Plus sign will come. Now I'll keep log sec x as it is. And I'll take differentiation of what? Please see here. I can add this as 2 into x power minus 1, no? 2 by x is x power minus 1. X is denominator. X power minus 1. Why? Because I wanted to write in the form of x power n. Please check. So I get this as 2 by x. Differentiation of this 1 by sec x. 1 by sec x. Because log is there, so 1 by sec will come in down. Then what? Differentiation of sec. How much will that be? Sec x tan x. Anything else? No, sir. Sec x, differentiation is sec x tan x. Nothing else is there, sir. Nothing else is here. This is secant x tan x. Okay. Alright. This part is covered. Now what else? This will remain as it is. Log of secant x. What is the definition of this? I'll take 2 outside, and this will become what? Minus 1 times of x power minus 1 minus 1. N minus 1, n is minus 1 here. So n comes as the coefficient, and n minus 1 is minus 1 minus 1. Nothing to be confused, sir. Okay. How much is this? Sec and sec goes out. I have this as 2 tan x by x plus log sec x log sec x, forgive me, log sec x, and this is with a minus sign, right? 2 into minus 1. So I can write it as minus log. See here, this all is in product, right? So 2 with minus 1, so minus 2. 2 with minus 1, so minus 2. Okay, so minus 2 I can write here also if you want. Minus 2, please check. 2 into minus 1, minus 2 is coming here. Log secant x times x power minus 2, right? Simplify this, what I'm going to get? dy by dx is equals to, what is y? Y is what? Secant square x power minus, secant square x to the power 1 by x. Now this whole bracket, I can take 2 common. I can take 2 common. So let's take 2 also common. Another one. What I've left here is tan x by x, and this is simply log secant x. This is upon x square, right? Upon x square. Please check. Upon x square. Correct, no? X, this is x power minus 2 will come as x square. Is this the answer? Okay, they have taken x square common. They have taken x square common. So let me take x square also common. I'll take x square common in the denominator. So if I do that, my final answer will look like this. Please check. So yes. Anything else? Okay. So let me take minus sign also common. I think they have taken minus sign also common. X tan x is coming first. Okay. Not necessarily. Oh, let me check. Let me check the. Just check the. Take the x square common. If I do that, what I'm gonna get? 1 second. Let me write it as, so sec square x to the power 1 by x divided by whole thing as x square. This bracket will come here. Now 2 I can write here only. 2 will come out because it's the product, right? 2 will come out. Now what is this? Simply I took x square common. So I have to multiply x here because there is only one x. I am taking another x from denominator. So I have to multiply another x in the numerator. It will become x tan x. If you're confused, do one thing. Bring this x square inside. Bring this x square inside. Cancel x and x. What is left? Only x in the denominator. So I can simply write this as x. Simply write this as x tan x. X tan x. I hope this is clear. Okay. This is clear, right? Very simple thing. Okay. Now what is this? Log of sec x. Please check. Please check the answer. What is the answer? Which option is correct? 2 sec square x 1 by x, x tan x minus log secant x. Option A is correct. 2 sec square x power 1 by x upon x square x tan x minus log secant x. Option A is correct. Option A is correct. Okay. Please cross check. Okay. Yes. Okay. Let's move on to the next problem. 9th one. If y equals to log tan x by 2, find dy by dx. This is a simple question, right? This is very simple question. So how will this look like? dy by dx will be, differentiation of log will be what, bacha? 1 by tan x by 2. है ना? 1 by tan x by 2, correct? And how will this look like? Differentiation, is it enough? No, I have to do for chain rule also. Tan x by 2 will become what? Sec square x by 2. Yes or no? Yes, sir. What next? What next? Please check here. I have to do for x by 2 also. Will be simply 1 by 2. I hope you know that. 1 by 2 is the coefficient of x by 2 and x will be 1, so 1 by 2 as it is. Now what I'm going to do, bring sec square here, write here 1 by 2. Write it as 1 upon sine x by 2, okay, sine x by 2, and this sec square you can write it as, not sine by cos, no, it's tan, right? So sine by cos, sine x by 2 by cos x by 2, okay. Tan x by 2 is there, right? So I can write it as sine x by 2 by cos x by 2, and this I can write it in the numerator, in the denominator like this. Sec square I can write it as over here, cos square x by 2, okay. 1 by 2 I've already taken in the front, okay. Now please check, this cos will cancel one of the cos from the square, so what is left now? What's left now? Y dash, dy by dx is simply y dash, so or write it as dy by dx only, no problem. Please check now, what I've left here, 1 upon, nothing is in the numerator, only 1 is there. So 1 upon, what is it? 2 sine x by 2 cos x by 2. 2 sine x by 2 and cos x by 2. Please check. 2 sine x by 2 cos x by 2, because one x cos and cos is already cancelled. So 2 sine cos, how much is that? 2 sine cos is how much? Simply 1 upon sine 2. 2 sine cos is sine 2 x by 2, right? Same angle will write. 2 and 2 will cancel each other. How much is that? Equal to 1 upon sine x, right? How much? Which is 1 upon sine x? 1 upon sine x is cosec x. 1 upon sine x is cosec x. C, option C. 1 upon sine x is my dy by dx value. Please check here. 1 upon sine x is my dy by dx value. So cosec x. Cosec x is my final answer. I hope this is clear. I hope this is clear. Very simple question. Very, very simple question. Okay. Alright. This problem, 10th one. Okay. I have taken a little more questions today. I wanted to discuss few concepts in the question. So I have taken more than 10. I hope this is okay. So session might go a little longer, but it's okay. Y equals to log of x plus root of 1 plus x square. Find dy by dx. Find by dy by dx. तो कर लेंगे. Simple है. नहीं कर लेंगे क्या सर? कर लेंगे सर. Every student of mine is very smart, or all of them are capable. Okay, just they need to be putting some work into preparation. Do not wait for somebody else to come and do your work, bacha. Okay, it's your exam, it's your competitive examination. You have to prepare. There's no one. Your parents will not come and prepare for you. I will not come prepare for you. Any teacher, any friend will not come and prepare for you. It's your preparation. It's you have to take the initiative. If you want to make a change in your life, anything, if you are think about anything that you are good at today, think about today, what you're good at. Let's say, sir, I'm good at playing badminton, I'm good at playing sports, music, talking with my friends. So for everything that you are good at, you must have put some time into it. You must have put some effort into it. Same way, if you want to get good at this preparation, when you want to get good at your studies, you have to spend some time in the same thing. So same thing is studies over here. So spend some time, make sure whatever you're doing, improve from your side. Do not, if you are lagging, if you're somebody who is lagging very, very, very behind, it's okay. Don't worry about it. Don't worry about the competition right now. What is your goal? To make yourself better. First thing is make yourself better. Then you think about competition. Okay. Wherever you are right now, you should be better than that in the next session. Okay. So whenever this progress should be there. Doesn't matter what you are. Okay, means where you stand in the competition. It's okay. Don't worry about that. Worry about getting better. That's the most important thing, bacha. So let's come back to the question. Sorry to take this time of yours. Y equals to log of x plus root of 1 plus x square. How will I do it, sir? There's no need of product rule, right? Because there is no multiplication of the functions. Only log is there. Again, I have to use the chain rule, of course, because inside of the log also can be differentiated. So I can write this as simply, sir, 1 upon x plus root of 1 plus x square, sir. Root of 1 plus x square, sir. Okay. Is this over? No, chain rule will be applied. How will I do that, sir? Differentiate this bracket, sir. So since that is plus sign, I can differentiate individually. So this will become, differentiation of x is how much? 1. Okay. I hope you know that. I hope all of you know that. And differentiation of this will be written like this. I'll do it in the next step. Right? How is this one? Using the polynomial formula. X power n. If x is 1, right? Then n is also 1. It will become 1 power 1 minus 1, which is 0. 1 power 0 is 0. If you're not getting it, check here. 1 power 1. Differentiate it. 1 power 1 minus 1. How much is that? 1 power 0. How much is that? 0. Okay, no. 1 power 0 is 1, no? Not 0. 1. Okay. Not relevant over here. I'm not doing the differentiation of x. Okay. Okay. Alright. This is x power 1. I wrote it as x power 1 power 1. This is x power 1. Actually, x power 1 minus 1. How much is that? X power 0. How much is that? 1. I wrote the base also as 1. It's not correct. Okay. It's not correct. Okay. Chali. The base is x, right? The base is x. Let's move on, sir. Okay. How will I do this? So this will be simply, okay. How much is that? Please check. Differentiate this. So first this is going to be what? I can write this as 1 by, I can write this as, just give me one more second. 1 plus x square to the power 1 by 2. Again exponential form can be taken here. How will I write this, bacha? 1 by 2, 1 plus x square to the power 1 by 2 minus 1. Correct? And what will this become? Please check. What will this become? I have to multiply this with differentiation of this also, no? Chain rule is complete. No sir, we have to do differentiation of this also. We differentiated only this part. I have to do the differentiation of 1 plus x square also. How much that will be? 1 will be 0 and this will be 2x. Please check. 1 differentiation is 0 and x square differentiation is 2x. You will not stop differentiating until unless you can get a result out of it. Okay, this is it. Okay. Alright, this is it. Please check now. So what is my answer? This is coming as 1 plus, how much is this? This will come as root 1 by 2 minus 1, minus 1 by 2 minus 1, minus 1 by 2, minus 1 by 2 means root will be there but in the denominator. If it was minus 1 by 2, means reciprocal I have to take first because of the negative sign. The power will be 1 by 2 only, so it will become root in the denominator. Root in the denominator, sir. Root in the denominator. Let's see. Okay, okay. So how will this look like? It will be, so first of all, if you simplify this 2 and 2 will cancel each other, right? This 2 and 2 will cancel each other, correct? Please check. Okay, yes, this 0 plus 2x will be what? 2x only, no? This 2 and this 2 will cancel each other. So how much I'm getting? I'm getting numerator as 1 plus 1 upon 1 plus x square in the root times x times or simply x and divided by the denominator. What is it? Okay, I don't have space over here. I've written so big actually. Okay, I have to make the space over here, sir. I have to make some space. Just give me 1 second, sir. Okay, so I'll write some of the steps here, half of the steps here, and I'll write rest of the half over here. Okay, so let's look this right now. Look at this right now. So if I take this, denominator will remain same, denominator 1 upon x plus root of 1 plus x square. This is the denominator, please check. Same thing I've written here. Now what is the numerator gonna be? 1 plus, what is it? X times of something. So x times of nothing is 1 is just 1. And what is this gonna come in the denominator as 1 plus x square. Power is what? Minus 1 by 2. This is what? This is minus 1 by 2. So it will become what? It will become root in the denominator. So I wrote it like this. Now please take LCM in this side. Take LCM over here, it will become what? I'll get it as 1 plus x square, 1 plus x square plus x divided by this thing will be, which will be taking as the LCM, will come in the denominator like this. This is the denominator from the numerator side, will come in the denominator like this. Please check. And this will be what? This denominator x plus root of 1 plus x square. Now please check. Correct, na? Correct. This is my y dash only, no? So I am getting my y dash from here as y dash equals to, please check, 1, nothing is there. This is cancelled. So 1 upon 1 plus x square in the root. 1 plus x square in the root. This is my final answer. This is my final answer. Please understand this. Final answer. Okay. 1 y dash equals to 1 plus x square. Might look complicated, so let me just give you the flow how I started. So first I took the function to the differentiation of the log. I again used the chain rule over here. Chain rule gave me this result. Okay, I took for this exponential form I only have taken. This is the coefficient is what? 1 by 2. So 1 by 2 came in front. 1 by 2 minus 1. N minus 1 is the formula. So 1 by 2 minus 1 becomes minus 1 by 2. Minus 1 by 2 means the power will go in the denominator, which means power will be 1 by 2 in denominator. So root is in denominator like this. 1 plus x square the root in denominator. Okay, sir. Again I applied the chain rule over here. 1 plus x square chain rule is 0 plus 2x. 2 and 2 is cancelled over here. I have x here left. I wrote x as it is. Okay, x as it is over there. Now if you check, this denominator was as it is. I took LCM for the numerator part. LCM was how much? 1 plus x square, which came in the denominator over here, and then I got this as x 1 plus x square root plus x. Same thing got cancelled. Answer is y dash equals to 1 upon root of 1 plus x square. They're asking us y dash only. If you want, I can write your answer here also. What is the answer? Answer is 1 upon root of 1 plus x square. Is this clear? I hope this is clear. Alright, so okay, this might be messy. Actually, I thought I should be able, I wrote this very big. I should have written small, then I would have been able to fit the answer over here. It's okay. Next one will take care of this problem. Okay, sir. Differentiate e power log of log x, log 3x is in product with respect to x. Okay. Can you see something here? Can you see something here? E and log together. E and log together means inverse. I can just take that effect out. So I can simplify this function given here as y equals to simply log of x, because e and log will cancel each other out. The effect will cancel each other out. I'll have log x. This whole thing will come as log x. And then what is this multiplied with? Log 3x. Log 3x. Now what we're gonna do? This is product rule, right? Log x into log 3x is product rule. Let's find it out. Simple question. What is going to be? Take log x differentiation. So keep log x as it is only. Like differentiation of log 3x will be what? 1 upon 3x times 3. 1 upon 3x times 3. Because differentiation of log 3x is 1 by 3x and the 3x differentiation is 3. Then what? Plus sign you're going to take. Keep log 3x as it is. Then what are you going to do? Differentiation of log x will be how much? 1 upon x times nothing, because x differentiation is 1. So what is this simplified as? Simplified as y dash equals to log x. So 3 log x upon 3x. So I can cancel this 3 and 3, right? Okay. So simply write it as log x upon x. Over here what I can write? Log 3x upon x. Please check. Log 3x upon x, right? X is the same denominator. I can take it common as log x plus log 3x upon x. Okay. Now please check here. Log a plus log b. Log a plus log b. I can write it as log a into log b by x. How much is it? Log 3x square by x, option B. Log 3x square by x, option B is my correct answer. Option B is my correct answer, sir. Moving on. Okay. E power x. E power x. How much is that? Please check. If the function is written like this, e power x, we have to use substitution here. We have to use some substitution here. Let's see. If you want, you don't have to. If you don't want to use substitution, you can do it directly also. But substitution make the work easier. Let's see how. So if I take this as, let's say t. Take this as t. What will this be, bacha? Y equals to e power t. What are they asking us to find? Dy by dx. How can I find if this is given in form of t? I can write it as dy by dx will be equal to d by y dt and then dt by dx. Correct, no? Chain rule is, this is the chain rule, right? dy by dt, then dt by dx. Correct? Okay. If I do that, what I'm going to get? What is my y value? E power t. It will be skipped as e power t only. Please check. Yes, sir. Please check, sir. Correct. Times of d of t. How much is t, bacha? T is e power x. So substitute it back. E power x to the power base dy by dx. How will this look like? Please check. Last step. Step 1, 2, 3 and 4th step. Dy by dx will be nothing but, please check here. If I differentiate e power t, it will remain as e power t. Differentiate e power x, it will remain as e power x. So what is my dy by dx coming as? Please check here. my dy by dx is coming as e power t will be e power x and times e power x. How much is that, bachcha? Option A. Option A. Am I right? E power x. How, sir? T is e power x. So I can substitute it back now here. E power x. So e power x is multiplied with e power x. That's your answer. So let's move on to the next problem. This was easy, right? This was easy, no? Okay. Simple question. Now this one. Differentiate cos of log x the square. Log x the square. So I can take over here. Let me see. Y equals to cos log x the whole square, sir. Log x the whole square, sir. So, okay, I cannot use product rule here. I have to use what, bachcha? I must use my chain rule only. So, if I do that, how this look like? Please check. Y dash will be nothing but, I'm going to do first for cos, then for log. First for cos, then for this exponential, this exponential function, this polynomial function, 2 will come in front, and then I'll do for log again. Please check now. So if I'm doing that, I'll get what? For cos, I'll get what? Minus sine log of x the whole square. Then what will get? Then I will get this value. 2 will come in front. So 2 log x to the power 2 minus 1. Please understand, what is this value? I'm using this expression, t square. I can take log as t, right? Then what will happen to this? It will become t power 2. How much is this will be differentiated as? 2 power t minus, or 2 power t power 2 minus 1. 2 into t power 2 minus 1. Please check here. 2 into t power 2 minus 1. Yes, sir. Okay. This is just to make you understand this. T square can be written as 2 power differentiated as 2 times of t power 2 minus 1. 2 times of t power 2 minus 1. Okay. Now what next? What next will come? Next I will get differentiation of log x. How much that will be? 1 by x. Okay. Let's summarize this in the next slide. So I get y dash as minus sine of log x ka whole square. 2 is there here. So I can take this 2 out. I can write 2 here. So 2 is there. Please check. 2 will come out like this, right? 2 will come out like this. And then I can write it as log of x power what? 2 minus 1 is simply log x. And this x will come in denominator, so by x. So I can write it as log x by x. Simply write it as y dash equals to minus 2 log x sine of log x the whole square, bachcha, divided by x. Any option like this? Doesn't look like sine, sir. Okay. This is sine. Okay. To 2 minus 2 log x minus 2 log x. Okay. Sine log x the whole square upon x. Option number D, sir. Option D is my correct answer. Okay. I hope this is useful to you. Simple things. Yes, sir. So we have covered today again logarithmic and exponential function with your some ITF questions also. We have solved a lot of questions today, right? There was a lot of energy required, I think, from my side and from your side. I hope the session was very helpful. Okay, I hope you were able to understand all the questions. If not, comment below. Okay, tell me what exactly problem you are facing. It's okay. You can just talk to me. Do not worry about what I'm going to think about you, what others going to think about you. Doesn't matter. If you have a problem, comment below and let me know. Okay, whatever I can do from my side, I will definitely try to do that. I will definitely try to resolve your queries, resolve your answers. Okay, with this I would like to conclude the session, bachcha. Okay, this was it. Had fun teaching you. Okay, so we'll meet you in the next session. Till then, keep working hard with a smile on your face. Today, have a nice day, and then come back, take a break, come back and study also. So for now, bye bye, take care.